Hello everyone, here's an explanation on assignment 4. Assignment 4 is dedicated to the study on motion of the robotic arm you previously created. First of all, you need to create the environment, download file floor from resources below. This floor file you need to download first. Here's how it looks like. So on this floor you need to locate your robotic arm in the middle, and then from the first assignment locate on these tables your model of the single part. Here it's also written: locate the robotic arm you created in the middle, place part from the assignment 1 to the environment. Then in this tutorial I'll show you how to animate motion of the robot arm. So you need to do the same as in the tutorial, then save animation as a video file and attach it to this assignment. The deadline is the next class. First of all, I will copy the robotic arm and open this file in SolidWorks. I copied it because we'll locate the floor here and other parts. For example, if you will need a robot for other tasks, you can take it from here, and here we create our environment we'll work with. So I go to the SolidWorks and open this file, robot copy, open. And I don't know what the problem with my file, but I need to show location to all of these parts again. If you open your robotic arm without any issues, you can simply skip this step, but I need to point out for every part. I don't know, maybe just Citrix problem, I don't know. So once I integrated the robot itself, I can locate the floor from resources. So insert component, search for floor, and edit. Here. Then we made the robot with the floor. Click on Mate. Select this point of the robot and this point of the floor. Click OK. And then we also need to locate part from assignment 1. Each of you has different parts, so every part for each of the students is different. I need two, so I'll copy them. Control C, Control V, and locate them above these tables. Doesn't really matter where to locate them, but I locate them in the middle. For example, if you want, you can change structure of this table if you want. Okay, once I created the environment, next I need to provide the control option for every side of my robot. For example, I want to control this movement with a slider, and I want to control each of the parts of the robot. So how to make that? We need to create the corresponding mates for it. So I click on mate, then I open this hierarchy here, and I select the corresponding links of the robot I need. For example, start from the base, link 1, so now I need to define relationship between two planes. I'll select two planes and then it will be more clear what I'm doing. For example, I selected one plane here on the base, then I select another plane on link 1 also. I'll select the front plane. So now I define a relationship between two planes. As you can see, the robot was rotated. So next, what we need to do here, go to the advanced mates and click on angle here. And in these sections, we need to define the working range of our robot. So here you can see the default angles, for example, 90, 180. So it's how our robot can be rotated in the environment. So as for these two parts, it can be rotated around 360 degrees. So here we select from 0 to 360 degrees. So the robot can rotate within this range. And I also install default position at 90. Click OK. Next, I will hide base as I don't need it. And next I wanna define the relationship between link 1 and link 2. So here I also select corresponding planes, for example, right, right. And we'll limit the angle here. So again, click on angle and then the working range of the robot. So here we need to check the working range. For example, if I here write 40, it means that robot will collide with another link. So for example, if we try 60, then it will be okay. So robot is not touching any other things. So we can, for the minimum angle, give it 60 value. Then for the up working range, we also need to select the working value. For example, I'll write 360. As you can see, it's not what we really need. So I'll try 300. And in that case, robot won't touch any other, this link won't touch any other link, so we can leave 300 here, and then we install the default value, for example 180. And check some values between them. 200. Okay. 180 and click apply. Next, I will hide the first link, and now we need to define relationship between link 2 and link 3. Again, I need to select some planes, right, example, right, and define angle here. The minimum one, well, you also can use 60 for example, and for up value here, value 60, upper value try 300. Okay, can probably also leave 300 and install a default angle, example 180, 180, 90. Zero. Okay, finally apply, and then so let's check here the behavior of the robot from here. Previously defined the 60. Let's try to go up 90, and you can see that robot goes this direction. So it's not correct. We wanna go with the clockwise direction, not the opposite direction. So how to fix it? Oh no, here. Example 60, 100. Yeah, you need to make it reverse. So try to select this. Again, check values 60, 90, 300, 0, 60, 200. Okay, so we need to give another value. Example, here we limit it at 250. So the up value will be 250, and the small value will be on the 60, so we won't touch this thing. Here you can see that from 60 to 250 we can go from this direction. So we won't go here, won't touch this zone. Again, 60 and 100, 200. So we work here. In range we can work. And here install the default angle 180. Next, I hide this second link and open the last link and make relationship between them. Here select top plane. You first of all apply the first limit angle and then work with the last part. Top plane. Again, click on angle. And check allowing range. Example 60. So leave it here 60. So we won't touch this part. Then for the upper value, let's check the middle value, which side will go. So we go this direction. It's okay. Try 300. So high value will be 300. And again, check that we work with that range. 200. Okay. And this will be our default position. So once we define the mates for every part of our link, we need to create the mate controller. So how to make that? We go to the insert mate controller, and here we need to select our previously created mates angles. So we select each of them. I hold shift and select all of them this way. So now we have working range. Here, for example, we can rotate our robot around, can control every angle of it here with the defined working range, these angles, and last one. So I install the default position. Where is it? This things here it's 90. Then here 180. Here 180. Here 270. So next, let's create some movements. For example, we wanna move our robot here to this element. So we can manually adjust every angle, but it will be really time consuming. So what can we make here is to currently go out of the mate controller and again click on mate, and we want to provide to our robot the understanding of this position. So we simply want to mate this point to this point, so our end effector will move to this point, but we don't really want to mate them, so we just use mate for positioning only. So we'll just move our robot here and then we'll remove it if needed. So next I click on this point and I click here, click OK. And be sure that you work under this toggle used for positioning only, otherwise it will be stuck here. So I click OK, and then I go back to our mate controller and edit this feature. So now our robot has a new position, So I click here, add the position with the previously defined angles. Add position, position 2. Next, for example, I wanna move back to the default state. So I moved to our part, and then I wanna move back to the default position again here. All right, 90 here, 180, 180, 270, and again click on new position. It will be our new position. Okay. And if we click on this calculation animation, we will see how our robot behaves in the environment with our predefined positions. So I click here and we will see the movements of our robot. Move here and back. And here you can change time if needed. For example, you can go with 3 seconds down, with 2 seconds up. You can see that robot moves here not very fast, and it moves faster to the back position. Probably it will be more clear if we install here 1. And again, calculate animation, slow more, fast. Next, let's move to this side. Again, currently I close mate controller and define new position here at this part. Again, I click on mate. Again, you need to use for positioning only, and then define the relationship between these two elements. Apply. Under this toggle, use for positioning only. Oh my god. What's the problem with my robot? Let's try another way. Use for positioning only. Oh my god. Coincidence. Why mates here not defined? Okay, I can't move this part. I can't move this part. Okay, let me try one more time. Mate. Here. Here. Use for positioning only. Okay. 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 Now it worked. I don't know what was the problem with the previous time. Now let's go to the mate controller. Again, edit this feature, and it will be our another position. So here we click add position, position 4. And after this position, we will move to the default position. So again, here our default pose, 90, 180, 180, 270. at position. Okay. And again here we also will move slow to this part, 3 seconds, and go back very fast, 1 second. So now let's try to click calculate animation and check whether it will work fine or not. Go here, back, then go to this direction, again go back. Okay, works. So after that you need to click save the animation as a movie file, robot copy, Microsoft AV, save. Then you need to select the compressor. Here you need to select the Microsoft video, other formats. The size of them will be higher, so this compressor will work better, so you'll obtain the small size file. Then you click OK, and here some warnings on image size. Here you click no, and the video will be saved. First of all, it will calculate every frame and record it, and after that the video will be saved. So this video you need to upload to the assignment. Again here the part for every student is different, so here I need to see your own model from the assignment 1. So and here is your video. The size of it is really small, around 4 megabytes, so you can easily upload it to the assignment. So here's a video you need to upload.